Hi everyone, I want to go over the first question on your homework of worksheet 5 so you have an idea of how we're going to go through and show our work and all that kind of fun stuff. So we did start by reading the question before we were cut off, and I couldn't share my screen, but we want to make a well-labeled diagram of the scenario. So it doesn't have to be well drawn, but it should be well labeled to get the point across. Don't make fun of my drawing. So we have our initial position of the car, and then it's going to accelerate. Hopefully it looks like the same car in the end. Feel free to, put as much detail as you like. I'm going to have this initial position be 0. Final is 28 meters per second. And it takes us 20 seconds to make that acceleration. If I can put some wheels on that one. So I think that's good enough. It helps us visualize the problem. We're labeling everything. So a good thing to have an initial and final scenario is that if you're putting velocities in the beginning, that's a sign maybe put a velocity in the end, or if there was a displacement or something. Part B, we're going to put that into a graph. So we need to make sure our scale goes from 0 to 20. So it's scaled out, so you could do it however you like as long as you use a majority of your graph. But I think this should be pretty much scaled to do every other one as 4, or every interval of time is 2 seconds to get to our 20. And then we're going to our velocity, top velocity of 28. So however you want to do that. I think last time I went every other was 5. That won't work. Sorry about that. Oh, every third I did is 10. That's what I did. 10. Cool. So then we know we're going from 0 meters per second all the way to 28, which that's probably going to be about right around here. And we draw that line the best that we can. You're probably doing it off of a graphing paper, which is fine. So now you have to ask yourself, do you want to use a graph to answer the question? Any features on the graph, on this velocity time graph, we can simply take the area under the curve. Or do we want to use equations? If you're rough sketching, that's fine to use that graph. But if it's like a lab or something where you want that level of accuracy, you want to use a computer-generated graph, or just know that your answer might be a little bit off from an answer key, or the true answer. So we were asked to list the given quantities. So I'm going to do like the math solution in red. I go by the guess method, which is just to write down together all of your givens. And this might be the approach if you're not going to draw a picture of the whole scenario, but at least for the beginning of the course, you probably want to get used to doing that. Okay. And then what are we asked to find? We're trying to find the acceleration. So what we need to do is find one of our 3 kinematic equations that will allow us to do this. So the one that will is this one, or I'm going to write it in another way. I'm just going to go the traditional definition of acceleration. That way I don't need to move anything around. And I have my final minus my initial velocities over my time of 20 seconds. And I get my acceleration of 1.4 meters per second or meters per second squared. And then there's my answer. So that was part I. Now I'm going to do part II. Pick another color. And we're now looking for how far does it travel. So this is part II. So again, we need to find an equation or kinematic equation that allows us to do so. So we definitely need delta x in there. In this case, either one will work because we have all the other variables. I'm just going to go with this one because it's kind of on our list. So I'm looking for delta x. This term drops to 0 because our initial velocity was 0. The acceleration that we calculated, and I'm kind of running out of space, I apologize, 20 seconds squared. So then we plug all that into a calculator, and it will spit out our answer of 280 meters. So the expectation is that you're going to show each step, identify your variables, definitely show the equations that you guys use, and just show all your work, because this is really where I'm going to understand whether you understand the content or the problem or the scenario, and the same thing goes for yourself. All right, so if you have any questions, please make sure to contact me on Schoology, and I'll get back to you. Have a nice day.